Good morning, dear students. In the last class of practicals, we have learnt the first part of the titration, that is the preparation of a standard solution. लास्ट प्रैक्टिकल में हमने स्टैंडर्ड सॉल्यूशन बना लिया था और आगे के पार्ट में नाउ वी आर गोइंग टू फाइंड आउट द कंसंट्रेशन ऑफ अननोन सॉल्यूशन. We are going to perform the titration of KMnO4 with ferrous ammonium sulfate, also known as the Mohr's salt. In the previous video, I have shown you the method of preparation of standard solution, and today I am going to use the same solution for the determination of the strength of unknown KMnO4 solution. Two solutions already I told you are in this experiment. The first one is the standard, of which the concentration is known to you, and the second of which you have to find out the concentration. So, let us begin. This is the solution that I have prepared yesterday, the same I am going to use. You can see it is very clear and transparent, that means it is a perfect solution. Otherwise, it should have turned into the brown. Now, the first task is today to understand the chemistry of this titration. What actually happens in this experiment? The KMnO4 reacts with the ferrous ammonium sulfate, and this oxidizes it to the ferric sulfate. From the ferrous sulfate, the ferric sulfate is formed. This is the chemical change that actually we study, and here the ferrous ammonium sulfate, this is a reducing agent or oxidizing. Yesterday I told you this is a reducing agent since itself is undergoing the oxidation process. On the other hand, the KMnO4 is undergoing the reduction process, it is an oxidizing agent, and by the mutual reaction of KMnO4 and ferrous ammonium sulfate, the redox reaction, we will study their total impact. Now, you can see here the 2 moles of KMnO4 are equal to the 10 moles of ferrous ammonium sulfate or Mohr's salt. This is the very important thing here. Since you can see the stoichiometric coefficients of both are different, right. So, directly you cannot use the dilution formula M1V1 is equal to M2V2. Here you need to account for these stoichiometric coefficients. How we will come to know that the redox reaction is complete? This we will come to know by the change in the color. The color of ferrous ammonium sulfate is transparent, right. The color of KMnO4, you can see it is magenta purple, right, and at the end point light pink permanent color will be obtained. As the light pink permanent color is obtained, this is the end point. Here we do not need to put any other reagent from the outside. This experiment is self indicator, right. What the formula we are going to use? This is the M1V1 is equal to M2V2, and on accounting to this, we have seen that 2 moles of KMnO4 are equal to the 10 moles of ferrous ammonium sulfate, that is why 2 by 10. This formula we will use for the calculation purpose. First, I am going to show you the procedure, how to conduct the experiment. This is what are the materials that you need at this stage: the KMnO4 solution, the ferrous ammonium sulfate solution, dilute sulfuric acid. Then the other materials that you need, this is the conical flask, test tubes, this is burette, and this is burette. Already I have filled it with the KMnO4 solution and fixed into the stand. this pipette. Only these are the things that we will need at this step. Yesterday I have taught you about the first part. Now, first thing I am going to teach you how to fill the solution in the burette. This tube is called the burette. First check whether it is properly closed or not, otherwise solution will start falling down. Use funnel, place the funnel here, then with the help of this funnel from the sides you fill the KMnO4 solution in the burette. I have already done this for you. Just to show how to fill this, I have shown you what the precautions that you need to take at this step. You can see this part is empty. You have to flow the solution very fast like this. Now, this will be filled and there should be no air gap. No air bubble should be there, otherwise the volume is going to change. To avoid this kind of the experimental error, you need to remove the air bubble, and for that you have to open the tap fast, right. Then you have to remove the funnel. During even exam I have seen some students place the funnel there. This is the mistake you do not have to do. You just have to fix it in the burette stand properly vertical, so that you can see easily. Now, what you have to do? Now, you have to take 10 ml of, I have used the burette. Before using any of the devices, you must rinse it with the solution that you are going to use. Do not wash it with the water, just rinse it with the solution that you are going to use. Already I have rinsed it with the solution that I am going to use. Again I am just going to show you how to rinse it. Take this small amount of the solution, roll it over and just allow it to flow. Now, your concentration of the solution is not going to change. Now, what you have to do? You have to take the 10 ml solution in the washed conical flask. It must be accurate, just allow it to fall drop wise drop. At this instance, you transfer it to the washed and rinsed conical flask. The pipette works on the theory of atmospheric pressure. See it carefully. Now, you can see one drop is left here. So, do not blow the air. The right way is just touch it with the wall of the conical flask. Now, this last drop will also go to the flask. Now, what you have to do? I have taken the 10 ml of the solution. So, I will take the half test tube of the sulfuric acid, dilute sulfuric acid you have to use. Last time, at the time of preparation of standard solution, concentrated solution of sulfuric acid was used to avoid the oxidation of ferrous into ferric. Now, I am going to add this half test tube of the sulfuric acid into this titrating mixture. This is called the titrating mixture. Now, from the burette I am going to add the KMnO4 into this, dropwise drop you have to add, and how long you have to add till you do not get a permanent light pink color. Now, I am going to add here, and continuously you have to stir, you have to be very patient with this step. Your initial reading should be 0, then you need not to fill it all the time from the 0. Whatever the reading is there, first you have to note it down. You must have to note it down so that you can calculate the actual amount of the solution used. Now, I am adding dropwise drop. This you have to do till the permanent pink color appears. I have performed this experiment beforehand, so that you can see, to save your time. You can see the light pink is the color. This should be your color, just a change in the color, not the dark one, right. So, beforehand I have done this experiment, and this is the result of that experiment, right. This should be your color at the end point. It should not decolorize. As you are going to add the KMnO4, at the beginning level the KMnO4 will turn the solution pink, but it will decolorize, right. But at the end point it will remain pink after the long time also. It should be the permanent pink color, and from this burette you have to find out the reading, what volume you have used during your experiment, right. In the previous experiment with this, when I have done the experiment, the reading was 8. I have started the experiment from the 0, and the last point was, the end point was 8. So, the volume that I have used is the 8 ml. Now, your procedure part is over. With this, the experiment has been done. Now, it is turn for the calculation and result, right. Now, we will use the formula volume of KMnO4 multiplied by the molarity of KMnO4 divided by the volume of ferrous ammonium sulphate into molarity of the ferrous ammonium sulphate is equal to the number of moles of KMnO4 divided by the number of moles of ferrous ammonium sulphate. That you will come to know from this equation. This is the equation, this is the chemistry of this entire titration process, right. From here, M1 V1 is equal to M2 V2. This formula here, M1 stands for the molarity of standard solution, V1 the volume of standard solution, M2 molarity of unknown solution that you have to calculate, and V2 the volume of unknown solution that you have used right now in the burette, right. And how many times you have to perform the experiment? At least you have to work for 3 continuous same readings. Maybe first reading will be dark, second may be light. How long you have to continue the experiment? Till you do not get 3 consecutive similar kind of the readings, right. Here, with the help, this formula works when both the stoichiometric coefficients are same. Otherwise, here we need to use the stoichiometric coefficients, right. So, here I have already converted it into this form. This is the formula that you have to use here. Volume of KMnO4 multiplied by molarity of KMnO4 divided by the volume of FAS into molarity of the ferrous ammonium sulphate is equal to the number of moles of KMnO4 and divided by number of moles of ferrous ammonium sulphate. This formula has, now you have to substitute the values. Molarity of KMnO4 you have to find out, right. So, I have just transferred all this to the another side. What the formula has become? The molarity of KMnO4 is equal to number of moles of KMnO4 divided by the number of moles of ferrous ammonium sulphate multiplied by M1 V1 that I have written here, volume of ferrous ammonium sulphate and molarity of ferrous ammonium sulphate divided by the volume. Here you can see this is the ratio of the number of moles, this is the volume of ferrous ammonium sulphate, this you have taken with the help of pipette, right, and this is the molarity. Yesterday you have prepared the 0.1 molar solution of the ferrous ammonium sulphate. So, from there I have written this. Objective also yesterday you have noted, divided by the volume of the KMnO4. At the time I did the experiment, the volume has come 8 ml. So, I have used the quantity here 8. So, from here I have come to the conclusion by the calculation, the concentration, the molarity of this solution is 0.025 molar. Since in the object it was given to find out the strength of the solution, right. So, now we have to convert this molarity into the strength form. The formula that we use to convert the molarity into the strength, that is gram per liter, this is equal to molarity multiplied by the molar mass. Here the molarity that I have calculated, that I have obtained here is 0.025. This is multiplied by the molar mass of KMnO4. The molar mass of KMnO4 is 158.03. Again, for the convenience in the calculation, I have used 158, right. So, 0.025 into 158, by the calculation I have come to the know that its strength is 3.95 gram per liter. This is the objective that we have achieved here. Our first experiment that we have studied from 12th class practical syllabus was the volumetrical analysis, and in these two experiments are in the syllabus: titration of KMnO4 versus ferrous ammonium sulphate and the titration of KMnO4 with oxalic acids, right. I am just going for a quick revision of this experiment. The first thing that you have to do, you have to prepare the standard solution of the ferrous ammonium sulphate, and by the formula of the molarity, you will first calculate the amount that is required to prepare the solution. With the weighing machine, you will take the exact weight of the solute, right. Then with the help of spatula and glass, you will transfer it to the volumetrical flask. This volumetrical flask I have used. Then you will add the directly concentrated sulfuric acid, right, and then you will add the water to maintain the level up to the 250 ml. This is the solution prepared. Now, in the second step, what you have to do? You have to take the burette. In the burette, you have to fill the solution of KMnO4. We fill the burette with the KMnO4 solution because it is the indicator, right. The end point you are going to get by the addition of the KMnO4, as the redox process will complete, right. After just the instance, the last drop of the KMnO4 will give the pink color, right. Be very careful at the time of adding the solution, add drop wise drop, right. A single drop can change your color. The color of the solution may be dark just by the single drop. So, be very careful at the time of adding the KMnO4 solution, right. First, what you have to do? You have to take pipette out the ferrous ammonium sulphate solution with the help of pipette. Before using, wash it and rinse it with the solution that you are going to use, so that your result is perfect one, accurate one, no experimental error is seen. Then after taking out, after pipetting out 10 ml solution, you just add half test tube of the dilute sulfuric acid. If your pipette is of 20 ml, add the full test tube of the sulfuric acid, right. Then you just add drop wise drop KMnO4 solution to the ferrous ammonium sulphate till the color becomes pink, light pink, just a change in the color like this, right. Repeat the experiment, note the reading by minor calculation, just final volume minus initial volume, find out the volume that you have used of the KMnO4. As you are going to get the 3 similar volumes, stop your experiment is complete, right. Then you do the calculation with the help of this formula. Please note down this formula, and you are not having the lab facility at this time. So, I will just request you to learn the calculation part. Take different values of M1, V1, M2, V2, right, and do the calculation. Definitely this will make you perfect in the numericals of the class 12th solution chapter also. This is the important part of theory as well as the practical. The second chapter is the solution, and this is the experiment from that chapter, based on the theory that we learn in the solution chapter. This formula we use so many times in the chapter also, in the theory also. Numerical questions are asked from this part. So, if you are going to make the practice of these type of the questions, your theory as well as the practical, both part will be complete, right. What are the precautions that you have to take during this experiment? First, do the weighing very carefully, take the accurate amount of the salt, right. Then it is a double salt, ferrous ammonium sulphate is a double salt. Do not forget to use the concentrated sulfuric acid at the time of preparation of the standard solution. Always and always, before using any of the apparatus, rinse it with the solution that you are going to use in that particular device, right, and add the solution drop wise. If you are going to follow these precautions, definitely your result will be correct. You will do the practical very smoothly and accurately. The accuracy is the main purpose to teach you this experiment in the video lesson, and I hope you must have learned the procedure, the method of calculation and the precautions of this experiment. I hope this video is useful to learn one core experiment that is going to score 8 marks in your practical exam, as well as for the sake of theory exam also you have to learn this topic. Thank you. Have a nice time, and please do the practice of these type of the questions. Again we will come with the new video of another experiment from your practical syllabus. Thank you.